So last class, I think we were trying to do this, no? Which was we tried having gold mine, and which was we were trying to add a cache to it, and we started doing the dynamic programming directly, and dynamic programming was working, and we tried adding a cache to it, and it blew up. Started giving wrong answers. So all I did here was
Can you
add the
present?
second, yeah. I'm not sharing screen. Yeah, very
No,
smart,
no.
very smart, very smart. Okay, so this is the one where which I was telling you that the issue was like, okay, let me run this. Okay, so this is the same grid we were using, and the problem is, where is that thingy called? Geeks or Geeks gold mine problem. Okay, so this is the one we were solving last day. And I think we solved it on one side using, I think we might have it still, no? Nope, it's somewhere else. It's a temp folder, so that's gone. But at least first thing we did last day was try to solve it using dynamic programming. So that was this part, and we tried adding a grid and the cache, and then things started going haywire. So what I wanted to show you was the smart technique I came up with. I still don't know why it doesn't work. So, okay, so this is what I had come up with. So I think, did you see the earlier wallet when I was using your idea of cache, it was giving the expected result, which is 16. But the moment I switch it to this one, it gives 7 or something.
It's
So even,
can you print the cache? Like
yeah, let me show you.
dimension to is same, no?
Exactly same. So let me show you the stuff. Okay, so I was playing around with this. So let's
Okay.
say I do this. Now the cache is there. Okay. So now if I use, say I use your methodology. So let's call it cache 2. Cache, look. Cache 2. Okay. Okay, so cache 2 is cache 2 is looks like this. Okay. Let's even do -1 for both. Cache 1 is equal to -1 times both. Okay, so I'm gonna print again cache 1, cache 2. Looks exactly same, right? So now
Right.
let's say cache 1, I want to change one value, like I want to change, let's say first row last value 0,3 into 999. Okay, I go to cache 1, it changes 999 for every.
Oh,
If I do cache 2, 0,0,
wow.
0,0 equals 999, and I print cache CS cache 2, it does it only one place. See, I have no
Right.
idea what is happening. The only thing I learned is like, do not touch that syntax. Like, if don't, I don't know what it's doing, but it's clearly, which was causing the issue, right? When we were replacing this guy, all the cache of 0,3, only thing it was doing was taking the final value and a cache of 3,3, and it was replacing only that with all the 4 values. So that's why it's like, okay, yeah, that is not working. Okay, so maybe today what we can do is, so let me also open Miro. Miro. This is the one we're looking at last time, I think.
But like, I'm still curious as to what is this functionality called and why is it replacing in every
I don't know. I broke
field?
my head over it for hours, and then I realized I'm not gonna have to try it. I gave it up, and I'll silently use your thing. So anyway, what we have been trying to do is this one, right? Recursion plus data structure is memoization. So we managed to do that here by using recursion plus data structure. Okay, so now the only path left is converting it to iteration. So for which there is one point I have been wanting to make in iteration. Okay, so if I draw here, does it show up where? Oh, perfect, came in. Okay, so I always want to go back, going back to the Fibonacci. This is 100%, which means my pen is too big. Shit. Fibonacci anyway. Okay, so Fibonacci, all I'm gonna do is 0, 1, 2, 3, 4. That's the index. Fibonacci, my values are 0, 1, 1 plus 0, 1, 1 plus 1, 2, 2 plus 1, 3. Okay, so then in Fibonacci, when we were doing recursion, we start from the top. Let's call this top. This is bottom. And now we start from the top. We ask the question like, what is fib of 4, which is tell me the Fibonacci number at index 4. So then we go top down because index 4 doesn't know the answer. It asks index 3 and 2. Index 3 doesn't know the answer until we hit index 0 or index 1, right? So that's a top-down approach. Me sitting in the middle is getting my answers from my child and returning it to my parent. So that is what my theory was doing. We did for us. Now, when we brought in cache, same thing. We tried filling up the cache at 0 and 1. And then again, we are starting, let's call it cache specifically. It's exactly the same column earlier, the row earlier, but I want to explicitly write it. So when we do fib of 4, what we're expecting is fib of 3 and fib of 2. Fib of 3 is fib of 2 and fib of 1. Fib of 2 needs again fib of, Jesus. Fib of 1 and fib of 0, and fib of 2 again needs fib of 1 and fib of 0. So what we're hoping is when we go down from 4, we hit 3, we're going DFS mode, we got 2, and we hit 1. At that point, 1 returns, 0 returns, and we have a new value for 2, which is 1. So we go fill index 2, 3, 4. So here is 1. So by filling that, we are hoping that next time when we come here, this is the overlapping subproblem, and that will be already taken from cache, right? So we were filling up the cache also bottom up. But now,
Can you scroll down?
I know you have to tell me that, okay? I don't seem to see that. Okay. So
No,
now,
I was imagining what you were writing.
no comments. At least note down comment later. So okay, I was saying, okay, now, so remember we were doing start with recursion, added data structure becomes memoization, add iteration becomes DP, right? So now in iteration also, we are pretty much doing the same thing, but the difference is we are going to start, let me actually write the function in iteration, okay? Iteration is def fib with iteration. So we only get int n, which is here, which is the value. I'm just mixing up languages, but that's okay. So what we'll do is cache of 0 is equal to 0, cache of 1 equals to 1. And the first thing we try to do is when you we probably need to have a parent function here. So let's call this helper, and helper is the one who calls fib. Def helper, right? Helper gets int n, and then we call the helper for fib, right? Def fib. When you get into fib, the first thing you will check is if what is n? If cache
Index.
of, you have to pardon me today, okay? If cache of n not equal to, my brain is like frozen. If cache of n not equal to -1, you return cache of n, else you just go fill the cache. No. So cache of n equals cache of nope. Fib of really frozen today. Fib of n-1 plus fib of n-2, and all we do is return cache of n, So there's one thing we have to do here, which is fill up there has to be a for loop which goes from for I in range of, where is that going to happen? In range
We
of
can start from 2 to n because anyway.
That's what I think. 2 to n plus 1. What am I doing here? All right, wait. I'm completely out today. My brain is frozen. But anyway, what I was trying to get to is we need to convert this to an iterative form. Please see if I try iteration cache. Okay, I have it. Okay. So yeah, so this is what we would do, right? Every time if you have fib of 4 and you come in, if it's not there in the cache, you fill it up with whatever value there should be fib of whatever. You see the point, right? I don't even know how this works.
Right.
But anyway,
Understood.
having said
That's
that,
what you wrote. You wrote almost the same thing only. Except the last number 25, you wrote everything.
so what I'm saying is, this is the iterative version of my Fibonacci, where all I'm trying to do is, when I try to run this guy, I'm just saying, come in, I'm asking for a fib of everything from 0 to 5. So it says fib 0 is 0, fib 1 is 1, fib 2 is 1 kind of thing. And we are running it from 2 to n plus 1. And when we are filling it up on the fly, so this way we have to just return once. This is not recursion anymore. And what I'm trying to do, the bottom line I was coming at is, when we do iteratively, we are actually filling it up bottom up, right? We came in with filling these two, but we are running the for loop from 2 to n plus 1. So we are literally filling it up 3, 4, 5. So that is the only thing you probably might want to keep in mind. Everything else remains the same when we go back to this one. How can we rewrite this as an iterative case? Remember, the question is, we have a gold mine. We are trying to maximize our entry into our pass through gold mine. We're trying to get the maximum value out of it. And we were doing it using recursive functions. So how can you write this iteratively? I'm going to even like copy paste this and call it new project. Save, new project, save, gold, EP,
You wrote mind.
Okay. Okay, so this is exactly the code we were using earlier. We already have the cache, and cache is populated with the last entries 5, 1, 3, and 2. So how can you write this iteratively? If it helps, we'll go back to the original lecture from last week. And so this was the gold mine grid we were trying to get to. And we were saying, okay, we tried filling up the cache. We did all the recursion, and our goal was, the parent is asking a question, and this was a top-down approach, right? Parent is asking a question, and me, who is sitting in the middle, asks answer to the child, add myself to my value to that, whatever was max, send it back to the parent.
Can you repeat
but here, this? Yeah, so this is exactly the parent-child I was saying. Like, this is the top-down approach we were doing for recursion. Recursion was, we started saying, hey, I'm going to ask the question of, let me open that particular lecture. Slide deck. Okay, so in recursion, so we saw that recursion in 1 dimension, but here in 2 dimension, what we were asking was recursion of this, right? We are saying, give me the value starting 0, 0, give me the value starting 0, 1, and then outside the loop in a helper function, we were trying to find the max of this, right? This helper function here. right? So this is the helper function. Right, so this is all we understand. This is all top down because it was recursion and the grid was getting filled bottom up also when we brought in the grid, which means we started the grid with this guy. We initialize it with this particular value. And we said, okay, if the grid is filled here, how do we fill the rest of the grid? Still using recursion. Same thing happened. The person came in here, asked, what is my value here? Then that person asked its children, this guy asked the children, this guy asked his children, and these ones are filled. So we start filling it bottom up, right? The grid is filled bottom up. But just now I told you in this one, it's also getting filled bottom up. The only difference is here when we have the for loop, like in remember in previous case, I lost it again. The gold mine Fibonacci iteration. So here we replaced, we filled the cache first. We have only one function, not recursive. It's not called anywhere else. Once we have that, we started filling the grid up this way. And all we did was when the grid was filled, I just returned the value of the grid. Using that knowledge, how can we incorporate that here? Like, how can we recursively do this?
Iteratively.
Sorry, iteratively.
Okay. One thought that comes into my mind is like how we save fib of 0, fib of 1. Same way we will hard code the first row, yeah, like line number 15 to 18. So that I think will remain the same. So that is a starting point. And from there, we will basically keep filling the cache matrix, and in the end return the last cache n cross n, the last value, the last block. And the logic is every time we are basically asking at this cell what is the maximum value I can achieve. And when
Okay,
we
so
go
what
to the end, that means
here?
that what is the maximum value that you got by traversing the entire matrix because you are at the last position. Something like that. I know I'm
Yeah,
not able to
but my
explain it
in this
nicely.
picture, where is your
Mhm.
starting and where is your ending?
So starting is 0 to 0.
Here,
Ending
okay.
is ending is m minus 1 and n minus 1. The last.
So what I'm trying to understand is, let's say we go back a little bit here. So this is for our iteration. Iteration may we have the same grid, which is, let's say we have this kind of grid and we initialized it with 5, 1, 3, 2, 5, 1, 3, 2. And you said you're asking the question here. Okay, and when you're at 0, 0, you will fill it with what? So this is called cache, and 0, 1, 2, 3, 0, 1, 2, 3. And when you said you'll be at m minus 1, n minus 1, but that is already filled.
Okay, I was imagining 5, 1, 3, 2 as the first column. So I think we will
Okay,
start from the end and go return 0, 0.
okay, perfect. So okay, fine. Let's see, let's take this example itself. So this is, only thing is we call it child, parent. What the other one was like recursion, this was top, this was bottom, and iteration, it is bottom up. We are starting from here. We already filled the first column. Now we are saying in this first column, what is my first value? My first value is, so okay, let's see what was the original value in there was 1. So let me also create an original grid here. So original, wrong window, original grid is really drawing too many lines. 13152241131522411. 502306. 5023 0612 and erase the last column. Yes, the mother Mithun. Okay, anyway, we got the point. All right, so this is the original grid. So let's say we are here at this grid, which is known as 0, 2, right? So my question is, what will you fill here? The cache of 0, 2, what will it be?
Sorry, I was on mute. 0, 2, that will be the maximum of 5, like basically the 3 directions.
Maximum of 0, 5, 1 plus the value there, right?
It's, yes.
That's equal to 5 plus 1, that's equal to 6. Okay, so the cache here will now be 6. Okay, 6. So let's say for the sake of argument, we were able to find this one also. Let's say for this one, you need max of 5, 1, 3, which is 5, plus 4, so this is 9. So the next one is max of 1, 3, 2. And this is 1, 3, 2. So this may say we have 3 maximum, 3 plus 2, 5. And this may say 3, 2, 3 is maximum, 3 plus 1, 4. Okay. So what my point is, sure, we can build this grid this way, up, bottom up, or however you want to look at it. What did you mean by the best value will be at 0, 0?
Mm. No, I'm just thinking if I said it right. So at every cell, we are saying what is the maximum you can get from my 3 possible direction. So yeah, at 0, 0, we are saying if we start from 0, 0, the maximum value that we can get is the value at 0, 0, whatever we'll calculate. So if our starting point is given, which is 0, 0, then we need to return whatever is we will calculate in cache 0, 0. But if our starting point is not given, we will just traverse the matrix and return the maximum value.
So my question is, so let's say it's the same question, like they're not telling you where to start. In the previous case, we picked 4 entry points and we decide what we did was we did a max of this in an outside function. Okay. So let's try filling this again, right? Let's see what happens if you start with your I want here, my max is 6, 9, and 0, so which is 9, my 9 plus 3, 12. Okay, this guy here, my max is 6, 9, 5, 9 again, 9 plus 2, 11. I'm here, my max is 9, 5 again, 9 again, 9 plus 0, 0. I think 9 plus 0, 9. And here it's 5, 4, and 0. 5 is my max. I add that with 6, that's 11. Okay, so from this point here, the 0, 0 onwards, what max between, it is 12, 12 plus 1, 13. Max of all these three is still 12, right? This A, B, yeah, still 12, so 12 plus 2, 14. And the max of this guy is 11, 9, 11, 11, 11 plus 5, 16. And this one is 0, max of 9 and 11, 11. Okay, so that's how we ended up picking 16, right? Okay, so now, we definitely need to have 2 steps. One is, in this particular case, fill up the cache. And 2, from first column, return max. I know what you are thinking was the edit distance, and we are going to solve that soon. But given all this, how will you rewrite this guy? Maybe I'm even
Okay.
thinking, okay, you tell me.
So like whatever how you dry run, right? Everything same way. If I try to convert it in code, so so since we have hard coded the last column, so I will iterate the matrix. I will have two for loops, and I will iterate them column wise
Hold on,
in
hold
the
on.
back.
You might as well, if it, do you want me to fill uh, the first column instead? Anyway, your call. You
No, no. First column, how can we fill? Like I was wrong when I said we
no,
will
I mean, I
fill.
can just reverse the whole thing. It's all a matter of perspective, no?
How come?
No, so all I'm saying is if I want to start filling up my first column, all I have to do is I'll start itself with what is it called? 5132, and start going building it this way. And this will be
Oh,
my
okay.
first column, and that's all. It's just a
Oh, you
direction
are looking at it in a
perspective.
no.
That, like I said, it's a matter of perspective. But if you're comfortable with this, what we drew, and you're comfortable with the for loop, let's do that.
Yeah. We are out of time, so do you want to do this as homework, or
No,
I can do it.
no,
Up to you.
I just want to go sleep. So let's
Okay.
finish this. So can you do this range of you start from m
Uh,
minus 1 and
this
go
is the
minus 1?
row.
Is possible?
Is yeah. So yes, it's possible, and then you need to give comma -1 if you want to reverse count. Yeah.
Range of n minus 1. N is the total number of rows, which is 4. We want to start from 3. And you end at -1 because you want to end at 0 and your step size is -1. Okay. What do you do here? For every column, cache of
Yeah.
comma j. So how are you planning to find all of your best values?
So we can check the three directions if that like um the three direction that we will be looking at should be in the cache itself.
So you're saying cache of what is right? So which is your
Right is same row and next column.
we use this. Yeah, so this will be cache of same row. We're going backwards. So it's I right. And next column, which is j minus 1. So everything is going backwards. I now agree why you said that. I is starting. So I is, hold on, I is here, 0, 1, 2, 3. So we should really be starting at 1, you know?
Mm.
All right. This is getting very complicated. I'm just going to, I cannot think other way around. So I'm just going to do this. I'm going to build it up from scratch. 0, 0, 0, 1, 0, 2, 0. You might as well hard code it. So I'm just going to say 5, 1. Oh, it's going to mess us big time. All right. It's because the other guys. All right. Just 5, 1. This is soon gonna come back and bite us, but that's okay for now. For I in range of 1 to m, she wrote lemma 1, so you go step by step. 1 to n. So you're saying r of I 1 comma j minus 1 to j plus 1. Sorry, j is also starting at 1, right? So j also is fine. So you can actually do I comma j is r value. You're down. The diagonal top is cache of I. So, what is it? J remains same. No, J anyway always goes to J plus 1. And this might be I minus 1. All right, man, I'm spaced out. So I'll let you do homework.